Hey, welcome back, science fans. We're going to have another one of Mr. Deming's lessons here. We're going to talk about seasons today, how the Earth's tilt is going to be causing our seasons, and how that tilt affects different heating on the Earth's surface. So, first thing we want to understand is that Earth's spins on what we call an axis, and that axis is actually tilted in comparison to the sun. So most people, when we see pictures, we see the Earth with its axis straight up and down. But if we were to draw a line straight out to the sun in whatever direction it's at, we'll find that the tilt of that spin is actually at 23.5 degrees, 23.5 degrees on average. Comparison to that plane directly to the sun. Okay. Now, I have a little model sun here that's going to kind of represent our sun. Not proportional. Okay, the sun is not smaller than the Earth. The sun is much, much larger, but that's what we get when we deal with models. So, let's start with the sun on this side. Okay, we're going to be able to see this okay in the frame here. Again, sun's very far away compared to size, on average 93 million miles away. So as the sunlight comes onto the Earth when the axis is tilted towards it, this is what we would call summer in the northern hemisphere. Okay, so we here in Utah are going to be experiencing that. So the sunlight, you'll see, has direct sunlight hitting it as it's on this side. However, as the Earth not only rotates per day, or it should be this way actually, as it rotates per day, it also is revolving around the sun. So we're going to do this really quickly. So as it revolves around to the opposite side, 6 months later we're going to call that winter, right? And so the sun, which would be in its same position, the Earth just goes on the other side, is going to be hitting the United States again, let's turn it here, at a much lower area. So the direct sunlight's coming down here more towards the southern hemisphere, less on the the northern hemisphere up here. And you see, the higher the latitude you go, both going north or the higher the latitude going south, it's going to get what we'd call indirect sunlight, where the sunlight comes more at an angle to it. And let me demonstrate that here with this little laser beam. All right, I'm gonna see if I can grab the picture here and get up close to, let's say, our Hawaiian Islands. All right, woo, if I can hold this still. So if I take this little laser pointer and just do a little laser dot like that, you can see that, this stays on, you can see that it has a nice round red dot. However, if I take my laser pointer, back up a little here, and put it at an angle, okay, we're going to see how that light gets a lot more spread out when it hits at an angle, okay, and that's what our indirect sunlight is. So we're going to get the same amount of energy from the sun because of distance, but when it's more direct like this, you are going to get a lot more of you're going to get all that energy concentrated in one small spot. But if it's spread out like this, all that same amount of energy is getting spread over a much larger area. So each square unit of area is going to get less energy overall. Okay, and so that's what's going to be affecting our different temperatures at our different latitudes. Okay, as you go further north, it gets cold to the North Pole and to the South Pole, right? But also with our seasons, instead of rotating around like this, let's just say that the camera's the sun here. So again, let's picture ourselves in the United States. When the axis is pointing towards the sun, we're going to get a lot more direct sunlight here. And you'll notice that in the summer times, you'll see the sun rising and setting much higher in the sky than you do in the winter time. Notice how that shift moved the United States up higher. So we're getting a lot more indirect sunlight, so not as much energy. And again, in the wintertime, you'll see the sun rises and sets at a much lower angle than in the summertime. Okay, so again, the misconception that most people have is proximity or closeness to the sun is what causes the different temperatures in winter and fall. Not true. It's going to be this direct sunlight and indirect sunlight as the Earth goes around the sun, and that angle truly affects it. If we take a look at other planets, we'll see that that's also the case, and the more drastic the angle is, the more drastic the seasons could potentially be. Anyways, there you go.